Hi, today we're going to work through a Webquest together on ionic bonding. Now you've had a really good introduction to ionic bonding already, so this Webquest is going to help you further understand ionic bonding. Now what I'm going to do is I'm going to read through the Webquest, and it'll ask sometimes to click on certain things, but I'll be doing that. You don't have to do any of that on screen. What you need to do is to answer the questions that as we go along, and I will give you a prompt when it's time to answer a question. I'll say, okay, go ahead and answer question number 1, question number 2 when it comes time for it. So I'll be giving you a little heads up on that. Okay, so I'm just going to read through each screen. So here we go. As the name implies, ionic bonds are formed between ions. The typical definition of an ionic bond tells us that it involves a transfer of electrons. While this definition describes very simply how an ionic bond is formed, it does not explain the forces that hold the ions together. In this tutorial, we'll look at how ionic bonds are formed, the forces that hold the ions together, and how the structure of an ionic compound relates to its formula. Okay, now you can answer question number 1. And I will say that you will probably want to pause the screencast when you start answering a question, because I probably will not allow enough time. So make sure you do that, to pause when it's time to answer a question. Okay. Before we begin to discuss how ionic bonds formed, we need to understand how charges interact with each other. The box below contains 2 negatively charged ions. Click and drag one of them closer to the other and see what happens. Okay, so I'll be doing that for us. Okay. Okay, now you can answer question number 2. Now let's look at how 2 ions with opposite charges will behave. Try moving one of the ions below closer to the other and see what happens. Okay, so I'll do that for us. So now answer question number 3. The oppositely charged ions attract to each other when they are close enough to stick together. Click the forward arrow to learn how what you have seen applies to ionic compounds. What you have seen in the last 2 screens is that charges that are alike will repel each other, while opposite charges will attract and stick to each other. In order to build an ionic compound that will stick together, you'll need both a positive ion and a negative ion. Okay, now you can answer question number 4. The positive ion will have to be formed from an atom that has a tendency to lose electrons. Since metals can easily lose electrons, the positive ion will usually be a metal. Atoms on the left side of the periodic table form positive ions. Now you can answer questions 5, 6, and 7. The negative ion will have to be formed from an atom that has a tendency to gain electrons. Since nonmetals form ions by gaining electrons, the negative ion will usually be a nonmetal. Atoms on the right side of the periodic table form negative ions. Now you can answer questions 8, 9, and 10. The information that we have seen so far leads us to the conclusion that metals and nonmetals can bond together by forming an ionic bond. Let's take a closer look at how this process works by seeing how an ionic bond is formed. You can answer question number 11. Let's choose sodium as the metal for our bond and chlorine as the nonmetal. Chlorine atoms have a strong attraction for electrons. Under certain circumstances, the chlorine atom will be able to take one electron from the sodium atom. When the sodium atom loses an electron, it becomes a positively charged sodium ion. The chlorine atom gains the electron and becomes a negatively charged ion that is, by convention, called chloride. Now you can answer question 12, 13, and 14. Okay, now you saw what happened. Since the two ions now have opposite charges, they will be attracted to each other as the ions we saw earlier. Let me replay that for you. Here's screen 11 again. Okay, now you can answer question number 15. The two ions are held together by the attraction between the opposite charges. This is called an ionic bond. Now you can answer question number 16. The process you just saw was a simplification of the formation of an ionic bond between sodium and chlorine. Let's take a look at this process again in a way that more closely resembles the way these atoms would interact in the real world. Chlorine atoms are usually found in pairs. Chlorine gas is made of these diatomic molecules and has the formula Cl2. Sodium exists as a solid made of individual sodium atoms. The solid can be heated and turned into a gas, forcing the sodium atoms to separate from each other. Each chlorine atom in the Cl2 molecule will require a sodium atom to react with. Let's see how this might work. The end result is that each sodium ion is bonded to a chlorine ion. But remember that opposite charges attract. Watch what happens next. The positive ions will attract any negative ions around them, just as the negative ions will attract any positive ions nearby. Other ion pairs nearby will also be attracted, building an ionic crystal. Okay, now you can answer question number 17. This continues in 3 dimensions until there are no more ions nearby. Click and drag the crystal below to see what this might look like. Okay, so I'll do that. You can see it in 3 dimensions. This is a salt crystal, sodium chloride. In the 3-dimensional model, we can see that each ion is surrounded by oppositely charged ions and that there are no distinct molecules. There is just a regular arrangement of positive and negative ions. Let's take a quick look at how we use formulas to describe these ionic crystals. Take another look at the crystal. Click on the buttons below to count the number of sodium ions and chlorine ions. Sodium 1, 2, 3, and chlorine 1, 2, 3. So now you can answer question number 18. There is one sodium ion for every chloride ion. Since the crystal contains each ion in a 1-to-1 ratio, we write the formula as NaCl. Now you can answer question number 19. In ionic compounds, the formula tells us the ratio between the ions in the crystal. It does not imply that there are individual molecules made of one sodium ion and one chloride ion. Let's look at another ionic crystal. Okay, answer question number 20. The crystal pictured here is formed between chloride ions and fluorine ions. In the boxes below, enter the number, calcium ions and fluorine ions. In the boxes below, enter the number of each type of ion present in the crystal. Okay, well, let's drag it around and count them. All right, the calcium ions are gray, so I see how many? I see 4. Okay, now let's count the fluorine ions. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's check our answers. Okay, the calcium to fluoride ratio is 4 to 8. Since this reduces to a 1 to 2 ratio, we write the formula for this ionic compound as CaF2. 1 calcium for every 2 fluorines. Okay, now you can answer question number 21. What you have learned in this tutorial should help you understand how ionic compounds form, the forces that hold them together, and how an ionic compound's formula is related to its structure. You've finished this tutorial, and you should have all your questions finished as well. Thank you.